11. So this is the explanation for the Boyles Law Lab write-up. So just kind of to remind you, our research question was like, how does increasing the pressure of a gas behaving ideally, so affect the volume of the gas whilst being kept under a constant temperature? And how can this lead us to be able to calculate the number of moles in the gas? So again, we're taking the big assumption here that we are using an ideal gas. All right, and again, we are assuming constant temperature. For this write-up, just to kind of go over, we're looking for you to have the background information and hypothesis. We want you to have the tables. Again, you might have one table or you might do two tables, one for raw and one for processing. That is up to you. We're also looking for graphs, potentially 2 graphs, or I would expect 2 graphs. Again, with this time, keeping your error bars like last time, looking at the trend lines, but this time we're going to take it to the next step and start adding in our max and min gradient. I also want to see observation and discussion about your uncertainties, and also your calculations need to be shown as well. Remember, one example calculation for each one that you do. We're also then going to look at a little bit of graph analysis and conclusion, referring back to that research question. Okay, so just to kind of go back into here, remember I've given you this write-up sheet with things like, again, putting your pictures in, so a little sort of text box here to show you how to do it. Also, we're using equations, making sure you use that equation function and can add in them nice and neatly where you define the parts of the equation below as well with your units. Please make sure as well any referencing you are doing. Personally, I always use MLA, but you can also be using footnoting within this. Right, so let's go to the help sheet. So we're going to start at the top. For your background and hypothesis, the main thing we're looking at here is the Boyles law experiment. So one thing that you're going to need to explain to me is what actually is Boyles law, okay, and kind of how does Boyles law come from our ideal gas equation? So maybe that equation also explained out. From this, you're going to then need to explain what the relationship is between pressure and volume. And again, with that, what graph would we need to sort of see to say the relationship between pressure and volume? But additionally, to kind of, if there are any further graphs that we need to do to prove that relationship. Okay, so again, we talked about if we have inverses, then we're going to need to plot an inverse graph as well. With this, from that, we're going to link to our second part of our hypothesis. So again, the bit on, it was on this one. The bit on here where we talk about being able to calculate the number of moles. So again, using our graph, we're going to have to use our gradient to do this, and we'll discuss that a little bit later. Okay, so I've put a little table up here, kind of putting my two things together as a one data table. But like I said, you might do a raw data table separately and a process data separately. So again, we've got our pressure. Our pressure, I think, was times 10 to the 5 pascals. And again, we were reading this off our pressure gauge, and so we should be able to see a plus or minus of what that uncertainty is. Making sure, again, your data in here matches your uncertainty within there. So again, you should be keeping your precision the same. Again, my volume, we had it in centimetres cubed. So again, I'm going to do my plus or minus centimetres cubed. Again, reading that from our equipment that we used. For processing, again, we want to put this into our SI unit. So for volume, we're going to have to go to meters cubed. So again, placing that in terms of meters cubed here, again, you might have a plus or minus with that to add in there. From this, we're going to calculate also the inverse volume. So going from volume to inverse volume, I'm just going to do 1 over it. Now, because I'm doing a 1 over, my uncertainty can be a little bit strange with this. So one of the easiest things to do is just change your uncertainty for volume into a fractional uncertainty or a percentage uncertainty. So if it's a percentage uncertainty of 2% for volume, it's going to be a 2% for inverse volume as well. Okay, so below I've just done a little calculation, again, sort of showing you here the fractional uncertainty, so absolute uncertainty of volume over volume. It's going to equal the absolute uncertainty of the inverse volume divided by the inverse volume. Again, just times it by 100 to turn it into a percentage. So then what we're going to then do is calculate our absolute uncertainty, so our numerical value of uncertainty for the inverse volume. And in this case, we're just going to take our fractional uncertainty that we have and multiply it by our inverse volume here. So we can take our fractional uncertainty which we'll have from this column, multiply it by our inverse volume, and that will give us our absolute uncertainty there. Again, in here you've got at least 1, 2, 3, 4 different calculations. These calculations are going to need to be shown. There were also some constants that you measured during the experiment. Thinking back to our PV equals nRT equation, maybe there was another one of those that you were measuring. And again, is there an uncertainty to go with that value? How are you going to display it on this page? All right, so let's go down to our first graph. So our first graph was looking at the relationship between pressure and volume. So I've just taken some data from here, pressure and volume, and we're going to be using Logger Pro. So I've got Logger Pro open, and I've got my volume and my pressure on here. So I've put pressure on my y-axis and volume on my x-axis. And again, you can click in here, put volume times 10 to the minus 6 meters cubed. So I'm just putting my values in so I don't have to write it out times 10 to the minus 6 each time. I can just put that in the title there. For pressure, I'm going to do the same. Pressure, it's going to be times 10 to the power, so I'm going to go to superscript, times 10 to the 5, close it, and then my units for this were pascals or newtons per meter squared, but we can just use pascals. Again, I've got this now written nicely on my graph. So I've got my volume graph, volume already in. I'm just going to copy my pressure across and go back to my Logger Pro. And if I add those in here, I can see this nice sort of curve shape appearing. Now I want to auto scale this so I can see it. I might want to see the origin, or I might try and bring this back a little bit. Again, I'm just going to click off to remove that yellow section. I've already added into here some error bars on, but I'm just going to go back and show you. So again, option, I might put in some error on here. So this was like 0.5, and maybe again on my Y, it was 0.0. I mean, it could be like 0.05. I'm just putting in some examples there of what you would have. Okay, so again, just making sure you go back, double click on your column, go to options, and then you can put them in as a fixed value. Again, not as a percentage, as a fixed value if you're just taking a direct measurement of them. All right, so at this point, we're going to want to put some kind of trend lines in. Now, last time we did a linear trend line, so we highlighted it and we added a linear trend, but that is not the graph shape that we're getting. So we're going to have to do something a little bit different. Instead, I'm going to have to go to a manual fit. Now, this is an inverse. Let's just try. I'll fit an inverse square? No, it's not, because it's not an inverse square law. It's actually, in terms of an inverse exponent is what we actually need. I'm saying this because a lot of the time students just go straight for an inverse square. They try the fit and then they go, oh yeah, that's a curve. And then they start trying to play around with this. Instead, look for here. This was an actual inverse exponent that we have. And I can see that's going through all of those. Now again, if I want to sort of take a few things in here, I can change my trend line to be a different color. So I might do that. I can change it. Let's just make it into the purple color. The other thing is I can see these little markers here that show me where the data is coming from. You can also remove that by clicking entire range. And again, we're going to want to screenshot that and put that into our data booklet. So, sorry, into our, not data booklet, sorry, into our lab report. So that's my first graph there. All right, now at this point, we're going to want to go on to doing our second graph, our kind of relationship to see if P is directly proportional to the inverse of volume. So we're going to just have another go with Logger Pro. I'm just